Hello, geometry people. Today's lesson is going to look at 4-2, triangle congruence by side, 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 and side angle side. So the last lesson, we looked at congruent figures, and I kind of stressed the idea that when you have congruent figures, you've got to look at all of the parts of one being congruent to all of the parts of the other. So what these lessons are going to do for the next couple of lessons is show us some shortcuts, all right? And these are shortcuts for triangles. Previously, when we looked at proving that two triangles were congruent to each other, there were 6 things we had to show. We had to show that all 3 sides of one triangle were congruent to all 3 sides of the other triangle. And we needed to show that all 3 angles of one triangle were congruent to all 3 angles of the other. Our shortcuts today, and we'll dig right into these, are called side, side, side. And I'll show you what the box in your books look like. Side, side, side postulate says if we can show in one triangle that the sides, the 3 sides, are congruent to all 3 sides of the other, then we can say the triangles are congruent. And so what I want you to notice is that AB is congruent to DE. So that's side, okay? We count that as 1. One side of one triangle congruent to one side of the other. That's 1. And then we have side BC congruent to side EF. So now that's 2 sides of one triangle congruent to the corresponding 2 sides of the second triangle. And finally, we have side AC is congruent to side DF. So now we have side, side, side. That's all 3 sides of the first triangle congruent to all 3 sides of the second triangle. Okay? So if you can show that all 3 sides of one triangle are congruent to all 3 sides of the second triangle, then you can say the 2 triangles are congruent. And I want you to also notice the way they're naming triangles. There's the triangle symbol in front of the letters that are the vertices. And then they use the congruency symbol and the triangle symbol with all 3 letters of those vertices for the second one, okay? So that is going to be one of our shortcuts. Now, the second shortcut that we're talking about is called side angle side. And the way this works, and this is important here because there is what's called an included angle, and that's the angle that's between the sides. So if I can show that 2 sides of one triangle are congruent to the 2 sides in the other triangle, and that included angle, the one that's between the 2 sides I'm talking about on both the triangles, if I can show that, then that's sufficient to say that the triangles are congruent. Again, you can make that triangle congruence statement. But it is 2 sides in one triangle with the included angle, the one that's between them, congruent to 2 sides and the included angle between those in the second one. Included angle is an important concept. Make sure that the angle that they're giving you is the one that's between the 2 sides. Notice this angle up here, let's look at angle B for a second, is not between the 2 sides that were given. So we're not talking about angle B. We're not talking about angle C. Angle C is not included between the 2 sides. It's not the angle that's between the 2 sides that it's showing on this triangle, congruent to the 2 sides on this triangle. These angles that are in between them are the included angles, and that's really, really important. It has to be the included angle. Let's take a look at a couple of problems here. Like you might see in your homework, the first one says, what other information would we need to show that triangle DEF, that's this one up here, is congruent to triangle GD, that's the one that's down below. And specifically it says using SAS, that we're going to use SAS, which is side angle side. So if I look at the diagram, I notice that EF is marked as being congruent to GD, right? Those two are marked congruent. And I also notice that FD is congruent to itself, right? Reflexive property. So we know EF and FD are congruent to GD and FD or DF. But what am I missing to do side angle side? Well, I've got a side and I've got another side, but I don't have what? I don't have the included angle. I'm going to mark in my book, which you should never do, but what we're looking for is what angle is between these two sides. So it's this angle. And if you go down to the other triangle down here, what angle is between the two sides we're talking about there? Well, it's this angle. We would need to know that this angle and this angle are congruent, okay? And so if I were going to name these angles, this is angle EFD. I would need to know that angle EFD is congruent to angle GDF. That's my missing information that I would need to know to show that these are congruent, that these triangles are congruent by side angle side. All of these that we're going to learn for the next few days are triangle congruence theorems, okay? That means we're trying to prove that the triangles are congruent to each other. All right, all right. Take a look at this one. What other information do we need to prove that triangle LEB is congruent to triangle BNL? So, think about what triangles these are. LEB is this top triangle right here. Being congruent to BNL, this triangle that's down here. What missing information would I need to say that those triangles are congruent? Well, let's look at the information that we have. I know that segment LB, right, or side LB is congruent to itself. So LB is congruent to BL. So I have side, right? And I know that this angle down here is congruent to this angle up here. So I have angle. I have side, I have angle. What else do I need? I need to know another side. But which side? Remember that side angle side requires that you have the angle that's between the two sides. So I would need to know that side LE is congruent to side BN. I would need to know those two sides are congruent, right? And if you're going to write down some information on that, you'd have to say side, right? Your little segment symbol, side LE congruent to side BN. There's the missing information that I would need to say that the triangles are congruent by side angle side. All right? And that's how I'd write it, like that. That's why it's important to know how to write things like segments and angles. Right? Right. Let's take a look at some other problems down here. So look at these two triangles. Is there enough information on those triangles to say that they're congruent? Well, what are our shortcuts? Either side, 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 or side, angle, side. Can I show these two triangles are congruent by side, side, side? No. And the reason you can't is because I don't have that this side is congruent to this side. It doesn't show that it is. So side, side, side's not going to work. Can I use side, angle, side? Yes, I can. This side, this angle, and this side, and again, I have the included angle, are congruent to this side, this angle, and this side, right? So these triangles are congruent by side, angle, side. Take a look at B. Is there enough information to show those triangles are congruent? Well, are they congruent by side, side, side? No. I don't have information on the third sides. This side and this side are not shown congruent. Can I use side, angle, side? No, I can't. And the reason I can't is even though this angle is the included one here, this one's not. These two angles, right, are not both the included angles. Therefore, I cannot say that those triangles are congruent. There's not enough information. Let's take a look at these. In part C, can I prove those triangles are congruent? Yes, by side, side, side. All three sides of one triangle are congruent to all three sides of the other triangle. Therefore, those triangles are congruent by side, side, side. Is there enough information here to show these two triangles are congruent? Yes. By side, 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 correct? Again, by side, 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 we can say they are. So let's take a look at these two triangles. Can I prove side, side, side? Yes. Can I prove side, angle, side? No. I can't prove side, angle, side because this side and this side, right, are congruent to this side and this side. But the included angle here would have had to have been here. This angle is not the included angle between these two sides. The one that's got 3 hash marks and the one that's got 2 hash marks has the angle between them here. Over here, the side that has 3 hash marks and 2 hash marks does not have the angle marked there. So it's not the same angle. It's not that included angle. So side, angle, side would not be able to be used there. Okay? So what we're really trying to do in this section is find a quicker way so that we don't have to prove all 6 parts of one triangle congruent to all 6 parts of another triangle. Instead, we can use the shortcuts that are called side, side, side and side, angle, side. Okay? That's the whole kit and caboodle. Now, let's take a look at some of these problems from your homework. Okay? I'm going to give you some hints on 9 and 10. F is the midpoint, which means that these two segments are going to be congruent. So that's giving you the whole thing, right? In other words, FG, if F is the midpoint of GI, then FG and IF are going to have the same measure. And so if I said this segment is the same as this segment, does that give you a hint as to how you can show those two triangles are congruent? Hopefully. But to do it formally, you're going to have to say that this segment is congruent to this segment. And I'll tell you why it is. The reason in your proof when you say that, the reason is going to be because of the definition of a midpoint. Okay? So it's not a very long proof, but you do have to write down some of that stuff. Let's take a look at number 10. What do you suppose we're going to try and do to show that those triangles are congruent? And again, make sure you understand which triangles they're talking about. WZD is this top triangle. And triangle SDZ, that's this bottom triangle. Those are the ones we're trying to show are congruent. Would we use side angle side? I don't think so. I think we can use side side. Now be careful, because they want you to use WZD congruent to SDZ, side WZ has to match up with which side? Hopefully you said SD. So in your proof, as you're walking through this and showing those things, make sure that you're showing side Z, WZ here, right? Congruent to side SD. And make sure then that you're showing side ZD, right, to side DZ. And finally, show side WD is congruent to side SZ. So WD is going to be congruent to your SZ here. Those have to be set up in that way when you do your proof. Right? Right. Okay. That's the lesson. Hopefully you got a good start, or gotcha, so you can get a good start on your homework for this. Make sure you look up what you're supposed to be doing. If you do have questions, make sure and contact me and let me know. Thanks for watching. Hopefully we'll get to see you real soon. Bye-bye.